All right. I think I'm ready to start now, and I think we've given a couple of minutes for everyone else to potentially show up if they needed to. So I'm going to, well, I guess get started. So hello all. My name is Neil Gampa, and I'm here to talk about the good, the bad, and the ugly at Datto for the Open Build service, of course, not at Datto the company, the Open Build service. So who am I? I am what I'd like to call myself a professional technologist. I've been a Linux user for over 15 years, and I'm a contributor and developer in Fedora, openSUSE, Magia, and OpenMandriva Linux distributions. I'm a contributor to RPM, DNF, and various related projects. I'm a DevOps engineer at Datto, so that's typically what I do. And so a little bit about Datto. It was founded in 2007. We have 17,000 plus managed service providers. We operate in what's known as the managed service provider channel. So we don't sell directly. We sell to other companies that then turn and resell our services to their clients and customers. We have 23 offices around the world, and we're 1,800 strong and growing. So we offer a wide array of services along the lines of unified continuity, so disaster recovery, backups, restores, things like that, networking infrastructure services, and products for supporting things like small offices and such like that, file sync and share product, and we do a lot of professional services, business intelligence and management stuff, as well as remote machine management. So what I'm here to talk about is like one of our infrastructure services that we actually use to support developing these products and services, which is, of course, the Open Build service at Datto. So just kind of a super quick recap, because we don't exactly have all the time in the world to talk about it. So the Open Build service at Datto has been in service for over 5 years now. It's deployed using the official appliance provided on the website in an all-in-one configuration. It runs in a virtual machine using container build environments, mostly for efficiency and resource reasons. Most of our software runs on Ubuntu, so we target that. However, we build all of our software with RPM spec files using a tool called debbuild, and the output packages are native, mostly proper Debian packages. We're building a library of RPM macros to port packages from Fedora and openSUSE to Debian Ubuntu using the debbuild macros, which is a project that we have where we're just filling in, writing macros to support the Debian way while providing the same consistent RPM-ish interfaces that are common on RPM distributions. We built the Datto Linux agent, which is our backup agent for our unified continuity products. So the agent that's used to send backups from a particular machine to our appliances. We've built them for over 50 distribution releases across the Red Hat, Fedora, Debian, Ubuntu, and SUSE families using OBS. We've got quite a bit more info about how we do this in our blog post and the talk I gave at the openSUSE Virtual Summit back in May. So if you want to get more details about that, you can check those out. And the links are in the slides that will be published shortly thereafter. So let's talk a little bit about the good that we've had with OBS. So the Open Build service has actually done wonders for us. It's made it possible for us to really make sure every single piece of software that we actually deliver to our internal infrastructure, as well as to our products and to the services that we run, it makes it possible for us to do it consistently and reproducibly. And it's great because, like, as resources grow and we need to as needs for building out software grows, we can scale the backend through adding additional OBS workers that automatically detect the orchestrator and auto-connect. And we don't really have to think a whole lot about maintaining the consistency of all the packages, because it automatically tracks all the reverse dependencies and rebuilds the packages on updates to ensure that dependencies are linked correctly. And because it's so easy to deploy and get started with, pretty much it's just grab and go when it comes to the production environment. But also it means that it's really, really easy for us to deploy staging and development environments for us to experiment with new features and new workflows without impairing the production infrastructure, which is something that's a bit of a rarity these days with a lot of different services that people push, especially in this cloud native era where a lot of services are just uber complicated for not particularly great reasons other than it makes it look great, which, okay. But most importantly, lets us build packages natively for RPM and Debian distributions using the RPM spec files, as I said before, with deb-build and the deb-build macros, which anyone can use. Those are actually in the openSUSE build service, and anyone can essentially configure their projects to use those for building Debian packages. But it's not all sunshine and rainbows, unfortunately. So there is some issues that we've hit over the years, and frankly, this has been very painful. So the OBS API is mostly undocumented, and it's extremely difficult to interact with. In the beginning, when I was first writing a lot of our integration for the build service into our infrastructure, I tried to use the API directly because I would figured it'd be faster. I'd be able to get it like more purpose driven, and in theory, it's a published API. But the problem is that most of the API is functionally useless. They exist, of course, but the documentation is either empty or very minimal. So it doesn't really tell you things like, well, how do you use this and what's the sequence of API calls and things like that. In the beginning, I tried to just kind of reverse engineer this by looking at the interaction flows that are done by tools like OSC, running OSC-D to see all those things. I gave up after a little while and decided that this was not worth the pain and agony I was inflicting on myself. And I instead decided to have our tools wrap OSC itself. This is bad, not great either, because it doesn't have a stable API either, and it has broken us a couple of times as new versions have come out. Like, some of its behaviors have changed in ways that have previously broken our behaviors. Consequently, I maintain a few patches on top of OSC for our use so that I don't have to think about this problem anymore, and that the behaviors remain consistent. It is extremely unfortunate, but that is unfortunately the way it is. And trying to fix these things has been less than ideal because the folks maintaining OSC, they do a lot of work and they try very hard, but there's only really 1.5 of them, and review times aren't that fast, and it makes it. I've had to make the hard decision of just shipping essentially a forked version of OSC to deal with that problem. And I wish this was better because I don't like having to do that. So on the next issue that we actually wound up having hit us over and over again in the face was that source services are unusable in a Git to OBS workflow. There's a couple of issues with this. The most serious one is that there's no support for Git webhook data to be used to configure source services. So in our workflow, we actually do, we maintain all the sources in Git, and when a pull request or a merge request, whatever term you'd like to use, is made, it attempts to test all of the changes, and then once it's merged and tagged, then we want it to be done on the build service. But we can't use webhooks to do this properly, and consequently, we've had to do some other interesting workarounds, which I will get to in a little bit to make that work at all. And so consequently, we just don't use source services for much of anything in Datto's OBS. I think we primarily use it for if we've got a spec file that we're having a third-party package. We will use the download files source service to download the tarball because it's from the internet and stuff, and who cares? But beyond that, we really don't use source services because they're just too inflexible and too painful. There's something that's actually come up a little bit more recently, like within the last year or so. There's no support for evaluating module dependencies for build environments. This is particularly crucial for when we're building for Red Hat distributions, such as Red Hat Enterprise Linux 8 or CentOS 8. There's a technology called application streams or app streams, depending on what you're seeing. This is based on a technology called Fedora modularity. And what this fundamentally is a extra metadata file for RPM repos that declares collections with filter rules that are expressed by the package manager to make sure that you can have multiple sets of packages, essentially using the same namespaces, but the package manager enforces that they cannot collide in the sense that you can't mix and match in broken ways. But at that metadata level, there's also a way of saying, well, this module requires the activation of this other module and these packages inside this module for this to work. OBS does not actually support this right now for modular repos. And so you have to manually figure out which modules need to be enabled and then turn them on one by one until your builds work. Not fun. I'm writing small scripts to essentially generate me that list so I can just paste it into the project config for an OBS project. But I mean, at least it can be worked around. But the one that's extremely irritating is that there's no support for evaluating file dependency properly in RPM builds. Now, technically, OBS can do this. It's not like libsolve doesn't know how to do it. However, the build service dependency resolver has this completely turned off. The reasoning I got a few years ago, I think it was like 2 or 3 years ago, was that it would cause memory exhaustion, but I don't know if I believe that. So, for now, what it requires is that anytime I have to encounter file dependencies, I need to manually repo query them and then fill them into the project config. This is not good. This also makes it extremely difficult for me to write portable packages that actually just work across distributions. In our packaging style, which to some degree is derived from Fedora's, but with some extra twists here and there, we rely on file dependencies a lot more because then it's a lot easier to make sure things actually work across different distributions. It's basically the only type of dependency RPM has that I can guarantee is a usable way to request something or request a resource at installation time. And the fact that OBS really cripples this feature is awful. Unfortunately, there's not a whole lot that can be done to deal with that right now, but that's made some that's led for some interesting compromises where I've had to write some I've had some workflows where I have to populate these file dependencies whenever I discover that this is a problem. Now, that's the bad parts, but there's also the fun, ugly parts where it's not necessarily good and not necessarily bad. Some of it's bad as a consequence of good, which is weird. So that's where the third category comes from. So OBS is very popular in terms of our infrastructure at Datto, and to the point that we now have so many requests hitting our API servers for the OBS server that we see 503 requests to the API a lot. It happens more than I wish it would, more or less on, I think, like a monthly or so basis, at least that, probably more frequently. I haven't been keeping track explicitly so. And because of so much API demands and my inability to find any useful information or get any useful information from anyone about how to scale this, it gets a lot slower and things become an issue. OBS API tokens are something that I was hoping would be useful and then turns out to not be. They can only be used for triggering source services, which I don't use. So they're not usable. And so what we wound up having to do is create a special user that is carefully managed for our CI infrastructure to use the OBS API. And that has unfortunate consequences too, but fortunately it hasn't been too bad. It's just irritating. there's no way for source services to access authenticated servers. So what I mean by this is, like, our Git server is authenticated. You cannot do anonymous checkouts of any kind. But unfortunately, the source services cannot be configured with either SSH or HTTPS credentials of any kind. So it can't be done. You can't have OBS pull the code rather than having. So we have our CI systems just push the code into OBS, which it works. It's fine. It's just annoying because that means that the CI side needs to know a way to access the OBS API rather than OBS just, randomly pulling the stuff from our Git server, which would be a lot less painful. And of course, as I said earlier about modules, the support's not great. This kind of goes forward that you can't actually publish or produce modular repos. You can consume them, as I said earlier, but you can't really produce any. And as this becomes more of an issue with Red Hat Enterprise Linux doubling down on modularity technology and using it for more and more things, this becomes more and more of a problem. I'm hoping that this will be something that will get resolved in the near future, but that's an issue. The OBS version control system is awful. It is unwanted, and it has interesting quirks. Like if you branch and merge, you lose the history in between. This is one of the reasons why the openSUSE infrastructure, the openSUSE project has changes files still, despite having a version control and every action going through version control, because that is not a reliable way to generate a change log. That's not true with Git, because you can merge and preserve history across merges. So we mostly ignore it. I mean, it's not a big deal. We just don't think about it. And so we wind up using Git as our source of truth. And we've written a whole bunch of scripts and tooling around essentially implementing the Fedora-style dist-git model for supporting our packaging workflows. And it occurs to me there is one last thing. Hey, you get a special point that's not on slides. Yay! When it comes to the interactions with OBS API and builders and stuff, it's quite difficult for us to keep it working if the interconnect goes down. So this is a semi-related piece. The interconnect, build.opensuse.org, is what we rely on to make sure we have our distribution configurations and have those populated and have everything working. When that goes down, OBS doesn't have a fallback to keep running with like stale data. It downloads everything over and over again. It doesn't know the meaning of caching. And so we wind up in a situation where, like, even though there's previous records of cached RPMs and debs, cached repository solver data, cached build configs and stuff like that, and resolver settings, it just throws it away and tries to fetch again, and when it fails, it just stops building. Not building isn't necessarily the worst thing in the world, because we still have everything that we did before, but it's pretty bad if you can't move forward. And so, like, this has an interesting consequence that we try very hard to not rely on a lot of the magic functionality of OBS. So we don't do things like substitutes. We don't use multi-versioning, multi-flavors. We don't use any of those features which rewrite spec files, except for the release field, because you can't really turn that off. So we try to minimize our reliance on the OBS magic features, so that if I need to build them manually by hand, I can do it. And that has had to happen a couple of times, but fortunately not too often. But it would be really nice if someday this was something that we had a solution for, like maybe build in a proxy, or like handle some kind of cache invalidation mechanisms so you don't have to keep hitting the interconnect. I don't know. There's something. But yeah, with all that, it's said, like, OBS has actually been pretty solid for us. And I want to make it clear that while there have been these kinds of problems, and this is really just a very short talk about our experience of trying of using OBS at scale for years and trying to really make this something useful for our company.
That's interesting.
Apparently, I can't say nice things about OBS before it starts doing that. I don't know what that says about my karma.
I don't know, but obviously you're displeasing some French raper fan.
Yeah. Well, in the end, like, OBS has been pretty awesome for us. It's just, these are the highlights of, like, hopefully a kind of balanced view of you know, where has it fallen down for us where it's done well and where it's fallen down for us in the past 5 years, so that people, you know, in the OBS team, in the openSUSE community, and others can, you know, build upon that experience and, you know, make it an even better solution for the next 5 to 10 years. So, any questions from the community? So,
how are you actually wrapping OSC? So essentially parsing std out?
No. No, that's I do that for exactly one thing, and that's for actually running. So in our workflow, and I mentioned in my talk back in the openSUSE Virtual Summit, we have a concept of scratch builds, which is more or less coming from Koji's model of, you can request from the API all the things you need to be able to build the package locally, and then you do the package build locally, or you can do the package build remotely and throw away the result. I attempt to mimic this in our CI infrastructure, and with that is the only piece where we actually shell out to OSC, because as it turns out, all the Python API inside is broken and you can't use it. But for everything else, we actually import OSC and use functions inside. I have a little shop of horrors of wrappers around OSC's API, the Python API of the OSC Python program, to do things like check out into an arbitrary directory, replace all the files and commit, set the commit message, things like that. And even have it do certain behaviors that the OSC client itself won't allow, which is, for example, work inside of a Git working directory. Because OSC broke that some time ago and I had to work around it. So like, I'm actually using the completely unstable API inside of the OSC Python code, because that's pretty much the only way you can do that properly, because shell parsing is even worse of an idea, because the output is less stable. So does that answer your question, Dan?
Yeah, definitely. So I won't try that.
Don't try that. What I was hoping for, like a few years ago when I was first starting to write these tools, there was this project called OSC2. And the idea that project was supposed to make a proper Python wrapper library for interacting with the OBS API. But nobody cared about it enough for it to keep going, and so it didn't. And with the lack of documentation in the OBS API itself, that project would not succeed without the backing of the OBS team. And the OBS team didn't care about it enough to keep it going. So, yeah. Any other questions? Or did I just kind of ram some terrible down everyone's throats and nobody wants to hear it anymore? Oh, somebody pointed out in the chat something called OBS Kit. Oh yeah, from what is it? Alberto Planos, right? From I know him. He works with the Fedora Rust SIG. Yeah, this is actually quite interesting because this attempts to pull the OBS data back out into a Git repo, and that's something that I've wanted to see for years and years and years. But yeah, this is very similar to one of the tools that I wrote for the Fedora Rust SIG, so that Igor Natenko, or now Igor Rates, he changed his name after he got married. Igor Rates wanted to be able to commit from Fedora's distgit straight into OBS and builds things from Fedora in OBS. I wrote a similar script that allows you to basically say, if you've got a distgit setup, it can just automatically push it back into OBS. And this is based on this some early version of the code that we use at work internally that I wrote adapted to Fedora's Git server. And so you can see from there, Dan, you can actually see example of how I manipulate the OSC API. But that's like one bit of some of the wrappers that I've written in. We have a whole program now called OBS-CTL, or OBS Controller, that I'm working through cleaning up and hopefully planning to open source, and then hopefully other people can see, what I had to do to make it work for our workflows.
So just another question, since you mentioned that there's some parts of OBS that you as a power user company are not really happy with. Have you or your management considered to, play by the open source spirit and hire a developer and implement this feature and try to upstream it?
I don't know about the hiring developer part, but I do, as part of the time I spend for my job, actually do work on OBS upstream. I've done
nice.
I've done work in the upstream project. I've done some testing. I'm actually slowly working through some effort to port OBS to run on Fedora. Because another thing that's kind of an ugly kind of thing is that openSUSE Leap is not fresh enough for us to be able to run the builders at certain points in time when like a new Ubuntu release comes out that we need to support, or in some cases a new Fedora release. openSUSE Leap 15 is not fresh enough or doesn't have the working functionality, and the OBS team hasn't done its own shop of horrors to backport stuff. And so it would be easier for us if we could run our builders on Fedora, for example, because then we have the newer stack, fresher, newer RPM, newer D package, all that sorts of things. So like we don't run into weird problems when the compression format changes or the repository metadata format changes, or some features haven't been turned on in create repo or stuff like that, which break our use cases. Because what I don't want to have to do is maintain a whole bunch of fork packages. I would much rather have them part of the mainline tree inside a factory, or in Leap or whatever. And I try my best to do that. I mean, I'm the maintainer of Create Repo C in openSUSE for this reason. I do a fair bit of work for this kind of stuff, and so yeah, like from that perspective, yes, we are in the open source spirit way actually contributing to the upstream projects. My involvement in the openSUSE project more or less restarted because we were starting to use OBS at Datto, and I was trying to fix things that were broken. So like, for example, the fact that full author identities are now in changes files, That was because at work, we did not like the fact that we couldn't attribute any changes people made because email addresses aren't enough. People can have email addresses and those can get reassigned, or they can become invalid or whatever. Or they could be aliases. For example, like there's somebody who has like the boss man at foo.org. Well, that's not helpful. That doesn't tell you anything about who that person was. And so I went through the effort of fixing the changes files and stuff like that to make it so that it produces for full names. And so that's why we have full identities. Anyway, with all that, I'm pretty much done and out of time. So thank you all for listening and attending.